Hello students, today we are going to discuss the fifth numerical of sedimentation. Question will be given as, in water three types of particles are present, that is A, B and C, and settling velocities are 0.05 centimeter per second, 0.03 centimeter per second and 0.1 centimeter per second. Settling velocity for all the particles, that is A, B and C, is given. Now if discharge of water is 2 meter cube per second, discharge is given as 2 meter cube per second, and surface area of the tank is 3000 meter square. Okay, now what percentage of particle will be removed? In the question they had asked us to find the percentage of particle that will be removed from the sedimentation tank if composition of the particle of A, B and C type are 30%, 30% and 40% respectively. Okay, so first we need to find the V naught value. Okay, first we need to find the V naught value, for which we need to write the given quantities here. Now for V naught, what will be the formula? V naught will be equals to discharge upon surface area, and discharge is given in the question, which will be equals to 2 meter cube per second. Okay, and surface area will be given as 3000 meter square. So we just put this value here, that is 2 meter cube per second divided by 3000 meter square. We get the answer as 2 divided by 3000, and it will comes out as 6.67 into 10 to the power 4. 6.67 into 10 to the power minus 4 meter per second. But settling velocity is given in centimeter per second, so we need to convert this value in centimeter per second. So in centimeter per second it will be equals to 0.067 centimeter per second. Now the overflow velocity or the loading rate will be same for all the three particles, that is A, B and C. Okay, so we will write all these velocities and the overflow or the loading rate. Okay, now in the table we had written here the properties, that is the composition, Vs, V naught, efficiency, final and the percentage removal, and in the horizontal direction we had written the particles type, that is A, B and C. Now the composition of particle A is 30%, which is given in the question, that is 30%. Similarly, the composition of particle B is also 30% and the composition of particle C is 40%. Okay. Now settling velocity, we had just written the settling velocity of all the particle. It is already given in the question that for particle A the settling velocity will be equals to 0.05 centimeter per second. For particle B it will be equals to 0.03 centimeter per second, and for particle 3 it will be equals to 0.1 centimeter per second. Now overflow or loading rate we had already calculated, which will be equals to 0.067 centimeter per second. Similarly for particle B it will be equals to 0.067 centimeter per second, and similarly for particle C it will be equals to 0.067 centimeter per second. Now we need to calculate the efficiency of A, B and C particles removal. Okay, now it will be equals to Vs upon V naught into 100. So if you just divide the 0.05 by 0.067 into 100, you will get the value as 74.63%. Okay, now when you divide the value, that is 0.03 divided by 0.067, you will get the value as 44.78%. Similarly, when we divide the value 0.1 by 0.067, we will get the percentage equals to 149.25%. Now we need to write here the final efficiency. 74.63% is the percentage which is generally feasible. Okay, now 44.78% is also feasible, but efficiency will never be greater than 100%, and for the particle C the efficiency coming out as 149.25%. so we had to make this 149 equals to 100%, because efficiency will never be greater than 100%. Okay, now when you multiply this 30% particle composition of A with 74.63 percentage, you will get the percentage removal as 22.39%. Similarly, when you multiply the 30% of particle B with efficiency 44.78, you will get the value as 13.43. Similarly, for 100% particle removal of type C, we will have the percentage removal equals to 40%. Now we need to calculate the total particle removed. Okay, now for the total removal, we need to add all this percentage removal of A, B and C, which will be equals to 22.39% plus 13.43% plus 40%. Now it will be equals to 75.81%. So 75.81% of particle A, B and C will be removed from that water. Okay, that is the answer of this question. Thank you very much, students.